Hi, this is Nimla Rednam. In this video, we are going to start the topic mensuration, which is the 9th chapter from NCERT textbook, class 8. Now, in the earlier classes, you have learned, the formulae for few basic geometric figures, formulae of perimeter and area, a few basic figures like triangle, square, rectangle, parallelogram, and trapezium and parallelogram, right? Now, here, what we'll be looking at in this particular chapter is area of any given polygon. Now, although we don't have a fixed formula for it, what we will be doing is trying to segment the given polygon into known familiar figures like triangle, rectangle, square, trapezium, so on, and then you can calculate the area piece by piece and then add it up to get the total area of the polygon. So that's what we'll be doing here. And then in the second and third exercise, we will be moving on to solid shapes, that is three-dimensional, where we will be looking at surface area and volume. Just like you have a perimeter and area for two-dimensional, we will be having surface area and volume. So the second exercise will be dealing with the surface areas of few standard solid shapes, and in the third exercise, we'll be dealing with the volume of those standard solid shapes. So let's write down the name of the topic, mensuration. Okay. So before going into the details of area for polygon, let us discuss about these terms, perimeter and area. Now, suppose you have a simple closed curve, right? What we mean by perimeter is the length of this boundary. So if you can manage to find the total length of this line, this boundary, then that is called the perimeter, right? So that will give you the perimeter of this particular simple closed figure, right? And what do we mean by area? Area is nothing but whatever is enclosed within these simple closed curve is nothing but the area. Now this is nothing but area, right? So we start with the simplest. First of all, finding it for any given simple closed curve, you cannot standardize and you cannot look at a formula for it as of now. But if you look at polygons, which are simple closed curves made up of line segments. So because I have line segments, I know how to measure the length of a line using a ruler. So I'm very comfortable with that. What we are going to do is find the length of each of these line segments and add them up. That is nothing but your perimeter. That is going to give you the perimeter. What is the area? Now, in order to find the area, you're going to, it's actually what you'll be doing is integration, which is calculus. But for the simple cases, like we start with with the triangle, to make it even more simple, you can try right angle triangle. What we'll be doing it is we'll be segmenting it into very small segments and then trying to find the total area. The cumulative of that is going to give you the area, right? So now, as you already are familiar, let's start with the triangle. For a triangle, what is the perimeter? Simply sum of all the three sides, and area is half base. One of the formulae is half base into height, right? You're already familiar with this. Now, if you look at the square, right? In quadrilaterals, you know the formula for a square, rectangle, parallelogram, as well as a trapezium. So let's start with square because it's very easy. So the perimeter is 4a, 4 times of this, and area is a square, right? If you look at a rectangle, I have length and breadth. Perimeter is going to be 2 times of that, and area is going to be length into breadth, right? And then if you look at parallelogram, I have base B, and if I have this height h, right, then this is nothing but base into height, and perimeter is simply sum of all the sides. If the sides are given, you can find the perimeter, right? So that is about a parallelogram. Next, let's come to a trapezium. You know that a trapezium is a quadrilateral with one pair of parallel sides. So if these are the parallel sides and the length is A and B of these two sides, and the distance, perpendicular distance between the parallel sides, if it is h, then the area is given by half h into A plus B. Now the derivation for each of these is, you can try it out, it's very easy, and once you keep, trying to look at the formula in terms of what is the reason behind this formula, it will become even more clear and there will be no confusion in remembering the formula. So this is trapezium, right? And you have a rhombus as well. In a rhombus, can I find the area? So here the diagonals are D1 and D2, right? If the diagonals are D1 and D2, then the area is given by half D1 D2, right? So this is the area. So these are a few of the standard area formulae for area that we have come across in our earlier classes. Now here what we are doing is, they will give us any polygon, some random, any number of sides, okay? We are going to try to segment it and into one of these familial, like triangle I'm comfortable with. As long as I have base and height, I can find the area. And if possible, wherever it's possible, I can have squares, rectangles, parallelograms, trapeziums, and so on, right? Depending on what is given to us. So for example, if I want to use the formula of area for rhombus, then d1 d2 I need to know the value of d1 and d2, right? So based on that, we have to each sum we have to kind of look into it and try to come up with the solution for the area, right? So here, for example, if you look at this figure, what they have done here, you can see here that you have a pentagon, right? There are 5 sides, A, B, B, C, C, D, D, E and E, A. Now what they are doing here is, they are joining AC, right? And if the length of AC and H1 is known, I know that ABC triangle is half B1 H1, suppose this is B1, right? And then there's one more triangle ACD. Now this is H2. If AD is B2, suppose AD is given to us, then this triangle is going to be half B2 H2, right? And then AED triangle is going to be half B2, same base, right? So it's going to be same B2 H3. Now I add these three together, I will get the area of the polygon. So that is the aim here, to try to segment it into familiar figures, and as long as the the measurement of the sides of those respective figures are known to us, we will be able to find the area of the entire polygon. So here if you look at the next figure, here you can see that AFB is again a triangle, we know the area of a triangle, and A, if I call it H, AH, okay fine, AED, I don't need H here, right? AED is a triangle. If I know AD and this height, I know the area of triangle AED, right? And similarly, ICDG is also another triangle, and you can find it. If you look at this FGCB, okay? So I'm talking about this figure. You can see that this is nothing but a trapezium. What is the trapezium? A quadrilateral with one pair of parallel sides. So what are the parallel sides here? FB is parallel to GC, right? So if the respective, like half h into a plus b is the formula for area of a trapezium, if I know the perpendicular distance between these two parallel sides and the length of BF and CG, I will be able to find the area of this trapezium. So that is how we will be, that is the approach that we are looking at here. So if you look at these, try these questions, they are doing the same thing here. They're asking us, for example, in the first question, they're asking us simply, tell me, how would you go about this figure, for example. Now this is again a pentagon, right? So FIE is no problem because it is a triangle, right? Whereas FIHG is still not good enough. So I need another line here joining G and I, right? If I join G and I, then this becomes a triangle and this is another triangle, and then I'll be able to find the total area given all the concerned side lengths are given to us, right? So here again, if you look at this, this is a hexagon. There are 6 sides over here, and we want to segment it in order to find the area. So you can see that only NQ is not going to help us. I need some more, segments. So if I join O and Q and M and Q, this is one method. There are other ways as well. I mean, there's no unique way of finding it. So if I join in this manner, then OPQ is a triangle, NOQ is a triangle, NMQ is a triangle, MRQ is a triangle, and together these 4 triangles will give me the required area, right? So that is how you're going to solve this sums. Now in the second and third, try these questions. They have given the side lengths and they're asking us to solve it. So we'll be doing it in the next video, and then you have few solved examples and then the exercise. So in the next video, we will be solving all the try these solved examples and the exercise sums of exercise 9.1, and then we'll proceed on to solid shapes.